Hello students, today we will be going over 16.2, using regression models to predict outcomes. Our objective, I can use regression models to predict outcomes. The regression model equation for the scatter plot is y equals negative 0.441 x plus 13.693. Use the equation to predict the value of y for x equals 19. So all we're doing is plugging in 19 right here. So we can go negative 0.441 times 19 plus 13.693. I take my handy dandy calculator. I do my multiplication first. And again, make sure it says, put the number in 0.441. Make sure it's negative, do the plus minus there, and then times 19, and then add 13.693. And the answer to that is 5.314. So we predicted that value. Use the equation to predict the value of x for y equals 5. So then what I do is I put 5 equals negative 0.441 x plus 13.693. Okay? Then what you have to do is subtract 13.693 from this side and subtract 13.693 from that side. So if I go 5 minus 13.693, I get the next equation, which is going to be negative 8.693 equals negative 0.441x. Okay, and then to solve for x, we divide both sides by negative 0.441. So I take negative 8.693 and I divide it by 0.441 and I make it negative and I get my answer. So x equals 19 point, and let's see how many decimal places. I'd probably say go to 3 decimal places, so round to the nearest thousandths. Okay, so then I got 19.712. Okay, next we're going on to the next equation, or next problem. The linear regression model equation for the scatter plot is right here. They kind of show you their scatter plot. The line is right there, and it kind of goes through the middle of all the dots. Use the equation to predict the value of y for x equals 100. Okay, stop the video and go ahead and do that one, and then predict the value for y equals 1. Okay. All right, I'll let you do that one on your own. I'm going to go ahead and do number 3 here. Stefan collects coins. He found that the number of nickels from a given year was related to the number minted or made that year. A sample of 1,000 coins contains 20 from a particular year. According to the graph of the model, how many would be expected to have been minted that year? Okay, so here's our number in the sample. So let's see. Here's the number minted in million, and here's the number in this sample. Okay, so if we have 1,000 coins contains 20, so 1,000 contains 20, so right around here. How many would have been expected to have been minted? The equation for the model is here. So we can go ahead and put x in for, let's see. According to the equation of the model, how many are expected if the sample is 23, if that were minted? Okay, according to the graph, how many would be expected to have been minted that year? Contains 20. So 20 in the sample right here would be what? About 900 million, because that's about 9 right there where 20 was. So I would put 900 million. So in other words, that's what x equals, is 900 millions, and y is approximately equal to 20. So they asked us kind of the question backwards, which is fine. But like I said, 9 over here, and it's in 100 million coins minted. So then it would be right around 20 in the sample. Okay. So we're going to use the equation the second time if 2,300 million coins were minted. So we could put 23 in as our x value. So we put 2.53. Let's put y equals 2.953 times 23, because it's 2,300 million, minus 2.93. Okay, then y equals, and I put it in my handy dandy calculator, again 2.53 times 23 equals 5.819. And I still subtract 2.93. So y equals 55.26. And that would be how many were expected in the sample. Okay. Jack invested in the stock market. The graph shows the value of Jack's investment over time. According to the graph of the model, how long did it take the investment to be worth $4,700? So here's your investment, $4,700, there's $4,500, $4,700 is right there. So we go across, and probably about 12 years. So I would put 12 years, okay? So here's the equation of the model. Using the equation, how much will the investment be worth in 20 years? Okay, so we put 20 years, that's our x value. So we go y equals 2920 times 1.04 raised to the power. Where's my power button? Shift 6. Okay. Raised to the power of 20. Okay, so on your calculator, you do have to do the exponent first. So I'm going to do 1.04 raised to the power, and I do that by y to the x, 20, equals 2.191, and then I times that by 2920. And I get $6,398.08. Because I had to, or 8 cents, I rounded up. Okay? All right. All right, go ahead and try the rest of this, students. You can get it. You rock.